Like, have you used something like KServe Saildown or BetaML, which is like a serving tools, or like Flask Fast API Docker, or like this is like your first time trying to follow a demo that do deployment, and hopefully this will be your first time deploying a model with ZenML and KServe. Oh, interesting. Like many people have used Fast API in Flask. Very interesting. All right, that's amazing. Okay, so like for many people, this will be the first sort of experience with the serving tool. I'm glad to see that. I think it's about time. Let's jump to the demo. So for this demo, we're gonna start with a very simple pipeline, like that have a like it's mainly focused on PyTorch, but we can also like sort of demo very quickly TensorFlow if that needed. We have in our pipeline a data loader. Then we're gonna train the model using PyTorch, evaluate that model, and we have another step which is deployment trigger. And in this step, we are like verifying if the accuracy is better than a specific score we do. If that, then we're gonna deploy into KServe. And for our stack, we have a local orchestrator, which will be used to orchestrate like our steps. And then a local metadata store, which is like to save all informations about what's going on, like with running our pipeline and everything. And then a GCP bucket, and this is very important because like since we have KServe deployed or installed in a GKE cluster, we need to save the artifact, the model artifact in the GCP artifact store, so the KServe can be able like to load it. Otherwise, if it's locally, like KServe will not have access to that. And also we have a security manager. This is also important because like since we just said that we are going to use an artifact, a GCP artifact store, we're gonna save the key for the service account that are responsible like for reading and writing from the artifact store into the secrets manager, and that also will be used by KServe in order to load the models. Now that we have like some sort of general overview about the stack and our pipeline, we're gonna first start by creating a new environment. So like I'm gonna do this just like how a user would want to run this demo. And by the way, like a blog post will be published tomorrow that explains exactly how you can deploy KServe in your Kubernetes cluster. For now, we're gonna just stick like on starting the demo. So let's do this. Let's call it something like this. Okay. Now, first thing we would want to do is to install ZenML.
I would assume we can ignore the errors.
Yeah, I think it has something to do with the version of Python. Okay, now we are good to go. So like now we have like ZenML installed, and like since our pipeline and our stack is made of like GCP stuff and like KServe, TensorFlow, and PyTorch, we need to install like all this integration. And for that, we're gonna use like this command that will install all the needed integration. Yes.
So Safwan, what is happening in the back now that you installed integration?
So now actually ZenML take care of like getting this specific integration required for like for this stack and the running this pipeline, and tries to install them in our virtual environment. like, and also take care of like getting the right ones, so we don't need like to handle dependencies, conflict, and all other stuff.
Very cool. If you have any questions in the meanwhile for Safwan, as obviously there's a few waiting times, please feel free to raise your hand or just speak immediately. That would be amazing. Yes, what's
Hey,
there?
hi, Amjad Tahir. This is from Suresh from India.
Hi,
And
Suresh.
we are getting a great support from ZenML, and we are able to run our AML components with the help of ZenML. We are progressing at a greater pace with the help of you guys, Amja and Adam. And I really enjoying working with ZenML. This is my feedback because I'm being working with MLOps pipeline for past 3.5 years, but we have bits and pieces where ZenML has been come up in a span of very short term, and it brought every integrations together, and our life are bit simple. There are some couple of challenges of the installations of dependencies that can be sorted out by the help of you guys, and I really I really want to thank your entire team, and you are doing a great job, Adam and Hamza Tahir and Sofen.
Wow. Nice, Suresh. Wait, so on the record, we did not pay Suresh to say that. This is not. Thank you. That was so amazing. I'm so glad you're enjoying it. Thank you for the compliments. I hope that there are many people also who feel the same way. And obviously, we're building the tool also in the hopes that you could use it, that you get faster in your MLOps development, that you can bring some order to the chaos of the MLOps ecosystem. Because when we created ZenML, the idea was there are so many cool and amazing tools in the ecosystem. Why isn't there something which connects everything together? And we feel like the community is slowly going into that direction where we have now Gemma. She's working at iterative with DVC. She's now here again. We're gonna hopefully release a DVC integration soon. We have KServe already launched, which Safwan is going to demo. So, and so many of these other tools. So I hope that it does give some order, which we also personally felt before creating the tool that was needed. So really appreciate your insights. Cool, Safwan, back to you.
Thank you so much. Thank you for your message. So now I think like we have our integration are installed. We're gonna need Torch Vision for this demo. So just gonna like install that quickly. And now like the second thing we need to do is actually like call the example that we're gonna use, which is like the KServe deployment. You can find it like in our repository in the examples. So as you can see now we have it, like we can do this, and like the following thing is to initialize the ZenML repository where like we have that demo. Okay, now that like we have initialized our ZenML repository, we need to start like to configure our stack, and we're gonna start with the GCP artifact store. And that's done using the following command, which is like ZenML artifact store register, the name, and like the flavor GCP and the path for the package that we're gonna use. We're gonna also need like the secrets manager, as we said. We're just gonna use the local one, like, but you feel free, like if you want to test this on AWS or like GCP, or, you can use another secrets manager, which is like a remote page. And like before actually registering the model deployer, we need to get something called the Ingress URL, which is like the endpoint URL that KServe will expose the prediction API into. And that's very important so we can run the inference later on. And also it's important because we're going to see some of the functionalities of this KServe model deployer that actually require the Ingress URL. So we're going to just execute this commands. Okay, now we can register our model deployer. As you can see, like the model deployer, we give it a name, which is KServe GKE. The flavor is KServe, and it has like a bunch of parameters. And this is like actually one of the main roles of the model deployer, which is the first one is saving the configuration attributes. It requires to do a connection with the KServe platform, like installed in the cluster. And some of these parameters are like
Shafin, one doubt, one concern here. See, are we not do we not don't we install Ingress here? Istio.
yeah, actually, we do install Istio like as part of KServe installation.
Because I have faced lots of issue in this area. Actually, we are unable to hit the endpoint. Even we configured the Ingress, we made up the Istio also, but we have faced lots of challenges when I was working with Qflow actually. So I hope that issue will be resolved today for me.
Actually, yes, like this blog post, as I said, like it will be published tomorrow. It has like full installation details that hopefully will solve your problem. So you
Thank
would
you so
just
much.
like follow it.
Thank you so much.
So now that we have like our model deployer is set, we can then register our stack, which have like the different stack components that we are gonna use. Let's give it a look and see like what are the components in our stack. Okay, as we can see. Now, the first, like the following thing that we would need to do is actually to copy the secrets, and the secrets is the service account that we generate that have access to the artifact store. So KServe can actually also like access it and get whatever model artifacts we need. And then after that, we can register a secret using ZenML secret register. And we have actually built a bunch of secret schema that are used. So one for each of the cloud providers that you can just give it the file of the service account, and it will load it and prepare it like for the model deployer. Now that we have like everything set, we're gonna try to run our PyTorch pipeline and starting by the deploy pipeline. Meanwhile, since this will take some time to run, let's take a look into the actual code and try to understand it a bit. So as you can see, we have our pipeline, which have like a data loader, trainer, evaluator, deployment trigger, and deployer. And then we have an inference pipeline, which have PyTorch inference pipeline processor, prediction service loader, and predictor. Now, I'm gonna just focus on the deployer mainly, since the other steps are a bit like easier to understand. So for the deployer, if we go to model deployer, as you can see, we have actually like a KServe model deployer step, which is like a pre-built in step by ZenML that you can use. And you need to give it a configuration. And part of the configuration, we have a service config that takes the model name, the replica, the predictor. This is like very specific to KServe. You need to specify a predictor, and the predictor can set the difference between something we call in KServe service runtime. So it's either PyTorch, Scikit-Learn, like TensorFlow, XGBoost, or any other, or even custom stuff. And the final thing, which is resource, because like we are using just a demo Kubernetes cluster here, I had to set the resource a bit low so we don't hit insufficient CPU or like memory. And the additional thing here, like which you could not find, for example, in the TensorFlow model deployer, which is the TorchServe parameters. And like to talk a bit about TorchServe parameters, like actually KServe supports deploying models with PyTorch, and specifically with a tool called TorchServe built by PyTorch team. And like this tool, actually, according to the documentation, if you want to deploy any model with PyTorch and TorchServe, you need to have it in the following structure in your artifact store, which is like folder for the config, which have config.properties, and folder for the model store, which have like the different model archived in a format called .map. And then if you want like to archive your model in that format, you would need to run this command, which called like Torch Model Archiver, a tool like brought up by their team. Give it a name to the model, the version, and like specify the non-network file architecture, the serialized or checkpoints for like you trained model, and something called the handler. And after that, you still need also to provide a configuration properties, and this is very important. So like TorchServe and KServe actually work. The good part about all this is that with ZenML, you don't need all that. You just need to provide the files, which is like the image, the checkpoint that you will already use to train your model, and finally the handler, which is like very important. Otherwise, what ZenML will do, and like the code built in, is try to generate by default a configuration file, and then sort of package everything for you, and also like save it exactly in this format in the artifact store without like needing any configuration or any other stuff. So after that, like once we have this all parameters, I think this is still training. There's one step left.
Nice. So, one maybe a quick question.
Yeah.
So now the model is being trained and it's being evaluated, and it will be deployed on KServe, which is deployed on a Kubernetes cluster, which is running on Google, right?
Yeah, that's true.
So a prerequisite of this step, as you said, would be to install KServe, but we can also automate that with the MLOps stacks recipes. But that's something that is coming up in the future.
Yeah. Actually, now we have Seldon and other recipes, and KServe like will be soon available part of that recipes, and you can just run like one script that will install everything for you, so you don't need to handle this. So now, as you can see, we have run like our model deployment, and deployment KServe model deployer step is done, and actually it returns an address for the model and also something called the host name, which is very important to run prediction with KServe. Now, if we take the same like code, and this time we run predict, we run the inference pipeline, and let's take a look to the inference pipeline. It actually load an image, like because like we are using digits data set. It runs an image of 0, load it properly by coding it into base 64, and now we can see that it's actually like running the prediction and returning the result, and we have our result here. Now that's it for like the pipelines and the deployment. But like the model deployer does not actually only save the parameter for connecting to KServe and also having pre-configured steps that will make your process easier, but also we have something called ZenML model served model command in CLI that you can sort of manage and interact with your models from the CLI.
Sofin, and I just wanted to look at the code of the serving one. Can you go a bit up? Did you mention that URL there? Address invoking this one?
Yeah, this is the URL and this is the host name required.
Okay, you should get go to this serving.
Sorry?
I think so. The question is that do we have to hard code this URL in the inference pipeline?
Pipeline.
No, we don't. Like just when we installing okay, let me go to the command. So when we are set up in like actually the model deployer and give the Ingress URL, which is like does not change, then ZenML integration, KServe integration takes care of everything, and it will give us this URL. So we don't need to take care.
Yeah. If you go to the inference step, maybe you can show them what that looks like in code.
So if we go to the inference, it's actually prediction service loader.
Yeah.
So it's just trying to load the service, like the prediction service, without even having like that URL hard coded. That will be saved directly using the integration.
Excellent, fantastic. It is because I faced lots of trouble to access that endpoint actually. So thank you so much. This could solve my problem actually.
Happy to hear that. So now, as we can see, if we do like list for all the served models, we have now like the in this PyTorch one, we can take this UID and do describe to get like more information. If, for example, like we don't have these logs anymore, we can still get this URL and this your host name, like just using this CLI command. As you can see, this is the URI, and this is like, we can see it here, and this is the host name.
And Sofin, one final question, Sofin, from
Sure.
my end.
You sure?
So this prediction URL we cannot access outside of the program, right?
No, we can actually. Like you can use it in any other program you want. This is generic, like related to your KServe and your Kubernetes cluster.
So we cannot expose it to the outside world.
Yeah, we can expose it to the outside world, yes.
We can expose, right?
Yeah,
We can.
you can use it in any other application.
Okay, got it. Thank you so much.
All right, so I think that's it for demo. I hope like you have a lot of questions and you actually enjoyed this, like the KServe. We would like to hear more feedback on you, like now and once you test this.
Amazing, Safwan. Thank you so much. That was really fantastic. I really love how the process is just importing a couple of steps in a pipeline. Obviously, there's a lot of setup that you have to do, but that's only once. After that, all your data scientists can just run these pipelines and deploy. Let's go to Subhabrata, who has a question, I think.
Hey, first of all, thanks for your arranging the demo. It was really nice. I'm following the ZenML for a quite long time. Yeah, I'm following the ZenML for quite a few for a long time. I'm also used Kubeflow as well as Selden as well. So my question on that part, is there any possibility you can provide a features like explainability, for example, something like that? Selden provide LEB, right? Is there any kind of plan is there?
Yes, we actually like have planned for that. Like we are planning to expand the models deployment story for first like support custom deployment, which will be released in the next release of ZenML, and also after that support the monitoring and explanatory of the model. So we actually have that on our radar.
Okay, great. Thanks.
And I think one of the, just jumping on that, one of the main differences between KServe and Selden is I think KServe is a bit more lightweight. So it doesn't have the alibi features, the ability to explain the predictions built in. So we have integrations into Selden and KServe. So if you have an explainability use case, then I think it might be better to use a Selden integration, because then after you do the same as Safwan showed you, it's pretty much the same in Selden. Then you could use Alibi straight with Selden and also include the Alibi code into your pipelines to maybe get some explanations of why the predictions were as they were.
Thanks for explaining, Hamza.
Amazing. We have so many people in the chat and 1 minute left. Is there any last question or a comment or anything for us today?
Sorry, yeah, I had a question just on Safwan's last comment, which was that custom deployments are on the radar. I would just be interested to hear what is meant by that.
So actually, like when you deploy in a model, you don't usually do just a deploy for the checkpoints. You would need to do like pre-processing and post-processing before and after the prediction. And that's now, like, since now we are using those like predictors or service runtimes, that's not supported, but like we have a pull request ready, and like it will be merged in the next releases that actually handle that. You can just write your functions that can do like your custom functions that can do pre-processing and post-processing for whatever like prediction you want, and that will be packaged with the model and deployed into KServe.
Oh, perfect. That sounds great. Maybe, sorry, if I could just extend on that question, is how is that limited, or is the goal there to limit that just to ML, or could we also apply that to sort of heuristic use cases, sort of long chaining of DAGs where you go through individual steps, which aren't necessarily about just pre-processing of data, but maybe are doing more generic operations? Or would you say that's not suited?
Actually, that's a very good question. And like the way we are implementing it right now, it actually support like whatever code you want to deploy. So it's not related to machine learning models, but like it's more sort of generic.
No, it sounds great. Thanks for explaining.
Okay.
Awesome. All right, we are 1 minute over time, so I wouldn't want to hold people back. I have left a lot of links in the text, in the chat, excuse me. I'm also going to stop recording. So